Hello, everyone. Mateusz here. I'll be the presenter for this webinar about strategies for on-premise and to Google Cloud migrations. Couple organizational things at the beginning. So first one is if you have some troubles or issues with the Zoom connection, there is a YouTube Live available. You should get the link on your email address. I encourage you to stay with Zoom because there is an option to ask the questions. It's called Q&A. I will try to address those questions as they pop up at the end of each section of the presentation. There will be also some time reserved for the questions at the end of the presentation. So without further ado, let's start. Okay, so first of all, who we are and why we are speaking on this subject. Why do we cover this topic? So, GetInData is a company that focuses on building the data solutions for different types of businesses. We are on the market for 6 years. We are more than 60 senior big data engineers on board at the moment. And yeah, we build white box end-to-end solutions using modern big data technologies, both on-premise as well as the cloud, so Google, AWS, and so on. We do things like creating and managing big data infrastructure. We do data engineering job, stream processing, analytics, automation, and data science. So actually the full package. And who am I? My name is Mateusz. I'm currently living in Krakow, Poland. I spent more than 8 years working with big data technologies, both on-premise and the cloud. But what's important in the context of the presentation is that 6 of those were with GCP. Starting from the early stages where a lot of services weren't yet available. I counted 5 different customers, so different companies, different environments. When I've seen where I was able to see the migration scenarios, it was a fintech, e-commerce, mobile marketing, and so on and so on. I also do trainings, some publications. You can find them on our GetInData.com page. And we also actively participate in the conference. This is something I forgot to mention here. We build a community around the big data via the Big Data Tech Warsaw conference, which is one of the biggest conferences related to big data ecosystem in Poland. Okay. Then when it comes to the topic, so first of all, let's address the question why companies are considering the move to the public cloud. As we can see from the IDC Institute, the study shows that there is a steady growth of public cloud on the market share. It's expected to reach about 40% by 2024. And what we've seen with the recent situation regarding the pandemic, things will probably speed up because things like remote work, internet businesses, and so on are seeing that there was an emphasis put on those services when we were forced to stay at home. So it seems like it gains a lot more traction nowadays, and becomes very significant part of the whole IT ecosystem. So what are the reasons? Let's see a couple of the examples. I've picked 3 cases of the migration, and let's see what those people who already done it or decided to make a move, what they think about it. So Spotify. To sum up, moving to the cloud allows us to move away from on-premise infrastructure and move up the stack. We can innovate faster by building services in this environment and finding better ways to build solutions that benefit our massive user base, taking full advantage of machine learning, data processing, and other opportunities. PayPal. We needed a partner who was also global and who could help us scale fast. It was huge for us that Google was already present in the countries we wanted to go. Instead of taking at least a year to get something set up in a particular country, we can literally flip a switch and have it available. And HSBC. HSBC now has around 170 petabytes of data on its servers. A year ago, it only had about 100 petabytes. This is what made us go to the cloud. Managing that much data takes a lot of effort and computing power. We found we were spending more time managing the infrastructure for data than we were using the data to figure out what our customers wanted. So let's point out some of the reasons that make you want to choose the public cloud. So first of all, this is flexibility in terms of how you can manage your resources. And it involves the ability to scale your resources, adjust them to the demand. This is especially visible in e-commerce sector, for example, on the Black Friday, because the resources utilization is the resources required to handle the growing load for that dates is definitely much higher than for the rest of a year. So with the cloud, we have the ability to adjust the computation resources and to handle to get this optimal, to get better resource utilization. This also refers to addressing different geographical locations, and it may be because of the performance aspects and the legal aspects. And with the cloud, we can shorten the time to market, entering a new country, entirely new market, because we can just put our services in a proper region, and we are already addressing this issue. There is no special research. There is no big effort involved with picking up partners, signing deals, buying hardware in that specific location. So this simplifies it a lot. There is the economical aspect. So as I mentioned, the resource utilization, but also all the savings we can do by making the cloud provider handling the dull tasks of managing the infrastructure. This is very important cost factor for a lot of the businesses, and we can maintain our budget in a very flexible manner because we don't need a long-term commitments. We can test things quickly. If something doesn't work the way we want, for example, we want to close specific region, or we want to shut down specific feature, we don't have a problem with what to do with all those resources that are now freed up, because we won't pay for them. Security and compliance is also a significant factor. It's usually, I guess you can ask yourself the question, if you can provide the security level of your infrastructure at the same level as the cloud provider can. For example, those cloud services are used by the thousands of people, and definitely they are rather more tested, more thoroughly tested than something that you have in your maybe data center or locally. Another reason is some features and some possibilities are available on the cloud only. So this is, I'm talking about the things that you cannot reproduce with the on-prem infrastructure because the scale of this feature or attributes of this feature make it just impossible or not very achievable with a limited budget. And a good example is the scaling capabilities for big data services, where you can actually, one single data analytics jobs can be spawned on 1,000 or tens of thousands machines, and you won't probably be able to reproduce it locally. You won't get the same level of performance because you are limited by some hardware properties like disk drive speed, networking connections, and so on. Even the space in the data center is a limiting factor here. And the last one, we will talk about it a bit more later in the presentation, but it's about transforming the way you tackle the IT challenges. To briefly describe it, cloud infrastructure is a bit simpler to manage than the hardware one. You don't need so extensive technical knowledge, and this allows people who are skilled with developing the software products to maintain this part of this part of the IT of the IT solution as well, because of that, you may want to restructure the organization to provide a bit more agility, so you can deliver new features faster. The business decision-making process can be sped up. Teamwork, connections between the teams may also be improved because those teams may focus more on the product-based thinking than on dealing with the exact tasks like infrastructure administration and so on and so on. We'll get back to this one. So migration strategies. How can we approach the migration problems? First thing is actually to pick the migration candidate. I would say it's not very reasonable to do the big bang move, like to move the whole infrastructure at once. What works much better is moving it piece by piece. And what is the good migration candidate that will give us the most business beneficial solution. So we need to, those are a couple of things that can point that migrating a piece of the software may be a good candidate for the migration. So first one is if you see that the software doesn't utilize the hardware very efficiently, so low resource utilization. Another one is rising performance requirements. This is especially visible for the data solutions as the amount of data is rapidly growing. And it's really hard to catch up trying to manage the infrastructure on the on-premise basis. So definitely cloud can help with that. High maintenance costs. So every cost that could be just, every complexity that can be taken care of by the cloud provider is a gain for us. So if we spend too much time on handling the infrastructure, maintaining it, making sure it's like up to date, secure, all the patches are enabled. If those are the problems you are trying to solve, cloud migration is a good idea. Also, actively develop solutions. As I mentioned here, you can iterate a bit faster when using the cloud properly. So definitely a software that is changing frequently or evolving is a good candidate to be migrated to the cloud. And one pretty obvious candidate is if you have any cold data archives. And by that, I mean, maybe you keep some a large volume of audit logs somewhere on-premise hardware, or you need to keep the data for the legal reasons, some financial data and so on. So this is definitely a good candidate to be migrated to the cloud. What to avoid as, let's say, what to avoid when picking up the system is the dissection of tightly coupled systems. What's important to remember when considering cloud migration is that the traffic between to the cloud and out of the cloud, which is like egress traffic, this is something you need to pay for. So if you have a system that's like has a heavy load and you move just the database part to the cloud, and this heavy load occurs between the system on-prem and the database. So in those cases, definitely that will just raise billing. Not to mention, you need to ensure the bulletproof network connectivity, which is not always easy when talking about the on-prem systems. Another thing that may cause problems is like third-party proprietary software, some old systems, let's say like IBM database and so on. So those are the things that are not easily moved to the cloud. Definitely, some of them are even hardware bound, so it's impossible to move. It may be a better solution just to try to replace it with something else that fits the business needs, but it's not the exact same solution. Another is, of course, licensing and compliance. So some of the solutions just you need to check if something can be utilized in a cloud environment, or there are any legal restrictions to that. And the last one is the legacy software, and I mean something that is very old. Probably a lot of developers in your company already forget about how to how the code was written. The system is running, fits its purpose, but nobody wants to touch it because everyone is afraid to break something. So this is like the end of life software, which is the problem that will solve itself over time and keep the lights on software. Okay, so regarding migration strategies, we can actually switch them to 3 main groups. First one is leave. So the things that we don't want to move to the cloud. So you have 2 options there. So you can either retire or retain the solution. As I mentioned before, this is the old software, something you may want to rebuild from scratch, something that there is no direct reason to move such piece of software to the cloud. So this is the first thing. Another section is another group of strategy is move, and move is the simplest migration possible. So what we do in the lift and shift category, you just rehost on the cloud with minimal changes. So we don't want to change anything. We just move it from one environment to another. Another is strategy is to replatform. So you move the piece of software, you don't apply any significant changes, just maybe some to make use of the cloud features. One of the obvious ones regarding the data processing systems especially is separation between compute and storage. And this applies to applications as well, because this one change will allow you to make use of the auto-scaling feature for a lot of the systems. And the last one group is the change. So we can refactor. So we are changing the application a lot, some development effort required, but we try to maximize the utilization of cloud features. And another one is replace. So we can pick some off the shelf, let's say changing one reporting system to something that's available on the market for a fair price, or we can use one of the managed services of Google Cloud Platform. How to decide between this move or change? So as you can see on the left side, you have things that you don't want to interfere with the application. On the right hand side, you have the significant changes. So it's the shallow migration is move, deep migration is change. And how to decide? Actually, it's a bit overgeneralization because it is very system dependent. But looking at the migration efforts, usually lift and shift it's a quick win, low hanging fruit. So it's easy to migrate. Vendor lock-in, which is describing on how dependent we are on the cloud provider after the migration, is also low, because since the move was pretty cheap and easy to do, it's pretty self-explanatory. The cost savings in the future, so the maintenance, maybe benefits that are coming to you from utilizing the cloud features here are also usually lower than if we utilize this the cloud features a bit better, but it's very system dependent. And the performance improvement, It all depends. In a lift and shift, we shouldn't see too much changes in the performance. Well, it all depends on how your hardware on-premise look like, but you won't be able to utilize fully the performance gains that are available in the cloud. On the other hand, when we decide to change, so to follow the deep migration, there is much more effort needed to perform the migration scenario, which may involve the development time required, but it's also switching to a new tool. So you need to, people need the time to learn. You need to figure out how to use the new service or tune it up to feel the to be able to replace without sacrificing any of the properties of the original solution. In this scenario, vendor lock-in is high. I would say rather high. There is a lot of ways to try to avoid the vendor lock-in. So picking up open source solutions or using containers and so on. Although if we decide on using some managed services, it may not be so obvious on how to replace the service in the future. So it's usually a high vendor lock-in. But we gain a lot of improvements in the cost savings area. As I mentioned, you can increase the resource utilization in this area, definitely. You can, for example, get rid of some maintenance. You can save time on the HA, so ensuring high availability, because you may get rid of some backup instances and so on, because this is already covered by the cloud provider. And also a lot of efforts for just keeping this service up and running is just taken over by the cloud provider. And the performance improvement, this is the same case. So definitely, if you learn how to use the cloud services and do it in a proper way, you will get definitely a lot. You can squeeze a lot of more of what cloud provider has to offer. So how does it look in the real life? So let's look at some of the services. First one is migrating some of the open source solutions to Google Cloud Platform. If you use Kafka, Elasticsearch, Redis, and so on, lift and shift migration seems to be a good idea. There is a lot of open source providers that are partnering with Google Cloud. So it's fairly easy to, for example, start a Kafka cluster on GCP. Additional benefits are that you actually get the SLAs on those services. You'll get the support from the cloud providers. This is not a vendor lock-in, since you are still using open source, and you'll have everything on a single invoice. So if you don't want to spend a lot of time on the paperwork, it's easy to just make use of those partner solutions and kind of also offload some of the management to the cloud provider. If the solution you are using is not on the partner solutions list, so it's not in this group on the right, you can look it up on Google Cloud Marketplace. So Google Cloud Marketplace is a catalog of services and deployment templates for those services to host them on Google Cloud. Some just for the example, GitLab, Jenkins. If you use SAP clusters, if you use Vertica databases and so on, you will find them on Google Cloud Marketplace. And apart from the support being a part of the Google Cloud offering, you'll get the same benefits. So you'll get, if you want to buy license for that, you'll get this on a single invoice. This is a very convenient way to just, instead of maintaining something on premise, just start using it. Just host it on the cloud. This is a very simple solution. Those are the curated solutions. They are tested with the cloud, so it should be pretty easy challenge to do. And what about other services? So this is a very brief introduction to some of them. Cloud SQL, which is a fully managed database service. If you are thinking on migrating your MySQL, PostgreSQL, MS SQL, if you use relational database, this is a place to go. Allows you to easily set up the database, configure it, scale it up and down, configure HA, and so on. So this is definitely like a lift and shift for the databases scenario. We have Google Cloud Storage, which is the, I would say, an online file system. So all object storage. If you have any binary data, text files, log files, and so on. So this is something you will look at definitely. BigQuery, I would say it's one of the best things that Google Cloud has to offer. So BigQuery is fully managed, highly scalable SQL-based data warehouse. This is not something that you can use to replace your operational databases, but if you do the all-up data questions, so analytical data questions, where you can wait a couple seconds to get the response, it handles really well. It's feature full of the features, and it can handle a lot of high load scenarios. So you can query petabytes of data with surprisingly good performance. Dataproc is something you would look for if you want to migrate the Hadoop ecosystem, open source. Dataproc is a solution which is built on Apache Top Hat project, and it's actually a service that's used for hosting the Hadoop and Spark clusters in the cloud in an easy way. Dataflow, it's a bit like Dataproc, like fits the same purpose. So it's also business analytics, but it's a bit different engine. If anyone of you heard about the Apache Beam, then Apache Beam it's a framework for doing the data transformations, data calculation, data processing. It can handle both batch and streaming, and it's very convenient to use, especially in terms of scaling and calculating a huge working in a high load scenario as well, I would say. Okay, so how could the decision tree for example, large data volume look like? So let's say we have a ton of logs on our on-premise hardware. So the questions we need to ask ourselves is it data that needs to be queried? If yes, If no, then we use Google Cloud Storage. Google Cloud Storage has multiple um, categories for the data, and if you use the right category, you pay less for storage, but more for reading this data. So if it's the data that we just need to keep and will probably won't read anytime soon, then we can, for example, pick the cold line cloud storage option. If this data needs querying, however, the question is, how often do we want to query the data? If we query them rarely, so like less than once a month, I would say, or we may be able, we may want to query it, but only if someone will request it. So for example, auditing, then we will choose the BigQuery with the external table. This is the feature that allows to use BigQuery as the compute power, so we can, but Google Cloud Storage for the storage layer. It's not as fast, but it's pretty convenient to use. So what about if we query this data often? Then again, it's a question of cost or convenience. And if it's about cost, then we could also use the same scenario. So BigQuery with the external table, so with data stored on Google Cloud Storage, because we can save a lot of money on this data compression. If we go for convenience, so we want to be able to query this data quickly, then we'll go for BigQuery and use a standard table which uses BigQuery as storage. We may pay a bit more for the storage and for the use, but it gets much better performance. We have this data validated. Yeah, there is a lot of benefits of using this one. So how about if we move want to migrate the SQL warehouses? I'm talking about Hive, Spark, or Teradata. So it depends. If it's a legacy software, so let's say we have an old data analytics job that was written in Hive or Spark, one thing we want to do is to, as I mentioned before, separate storage from compute. And this would allow us to not to keep the cluster online 24/7. We can then just run this cluster, calculate the results, and shut it down so we get better resource utilization, but we don't modify the code. So if that's the code we don't want to modify, it's a legacy job, we may not have business knowledge or time, or we may not consider it worth rewriting, when we would use data pros just to rehost this job. If we are want to recreate the same analytics and spend a bit more time and get more convenience at the end, then we will probably target BigQuery. I would say for every workflow that could be represented by a SQL, for most of those, SQL is the better option because it's much easier to maintain the SQL script than for example, Java code base or something like that. Yeah, so if we are going for the cost, it's like the same thought process as was before. So the BigQuery and the external table, which is backed up by Google Cloud Storage. And if we go for performance, then we could use BigQuery standard table. Let's park it right now. Let's answer. I see that there is a question coming in. Michael is asking, what's the difference between Cloud SQL and the BigQuery? Okay, both are the databases that you can query using SQL, but they fit a bit different purpose. So Cloud SQL, it's for managing the operational databases. So usually if you have the amount of data that is easy to be handled with the good performance on the SQL database, you rely on low latency response. You expect a lot of load on this table, like hundreds or thousands queries per second. You will pick something from Cloud SQL. If you expect a huge load or growing amount of data, there is a special kind of database for that. You would like to have a look at Cloud Spanner. BigQuery is something that's used for the analytics. So it usually won't give you a result in a time shorter than a couple of seconds. But it will give you a good result if you query, for example, 0.5 terabyte of data. So this is the first important thing. The other one is the billing and pay-per-use model. So for Cloud SQL, you pay for the database instances. For BigQuery, you pay for storage and for the amount of data your query have read. So as I mentioned, if you have a scenario where you query your database frequently, then definitely go for Cloud SQL, especially if it's an operational database. If you have data analytics to do, so something that you need to do the dashboard once a day, or you just digging into the data, you will pick BigQuery. Okay, back to the database, back to the presentation. Just to sum it up for the SQL warehouses, so just to summarize, if you can, if you want to move it as it is, just a short time and so on, lift and shift, do the data proc. But it's a huge, I expect you'll get the huge performance improvements replacing it with BigQuery, either for the external table, so storage on GCS, or the standard table, depending on if you value the cost benefits or performance benefits more. What about complex analytics? So this is something that it's not Spark SQL, it's not Hive. You'll have some kind of code. Maybe it's Python, maybe it's Java. How would you tackle something like that? So again, if it's a lift and shift and you don't want to do anything else, then separate storage from compute and use the Cloud Data Proc. If you want to do a bit more, then ask yourself, how complex is it? And by that, I mean, if you can replace this complexity, which you couldn't do with SQL, with user-defined function in BigQuery. Sometimes those things are pretty simple. Like one of the examples is maybe calculating some kind of statistic based on the some kind of fancy average or something like that. You couldn't find a function for that. If it can be done with UDFs, then go with BigQuery because SQL is much easier to maintain. If it's a more complex, or especially if you are using some third-party libraries, a good example is user agent parsing, then there is one more question. Is performance a key factor, or how much time you want to spend if you are willing to rewrite this job to get the best possible results? If no, then just lift and shift to Dataproc. If yes, then you may consider moving it to Apache Beam and run it on, rewrite it with Apache Beam and run it on Dataflow. Because the way Dataflow works and how the framework was written, it's much more aware of the amount of the data. It can scale much faster. Something that's also recently introduced is the shuffle. So shared shuffle provided by the cloud provider, which is the area where the data, how the exchange of the data between the machines is handled. So there is a huge chance you'll get much better performance results. And by that, of course, resource utilization and lower cost than for the Dataproc. And speaking of machine learning jobs, so if you have some Spark-based machine learning, then if you want to do it the shortest possible way, just rehost it on the Dataproc. If no, if you are using, there is a lot of libraries, and if you are using some third-party software, you will need to start from the scratch. And if you start from the scratch, definitely use AI platform. The only other scenario I could think of is if you already use Kubeflow. Kubeflow is a solution that is like a toolbox for machine learning. It's open source. It can be run on Kubernetes. And if you use it and like your data scientists are already familiar with that, then maybe best option would be just to rehost it on Google Kubernetes engine. Otherwise, AI platform, which actually uses the same features as Kubeflow and uses Kubeflow under the hood, will be the best solution, as it's just a bit more managed by the Google side. So those were this couple of scenarios which could happen. They are kind of skewed towards data processing, data analytics, and data-oriented solutions, because this is what we do. And this is not the optimal, the only ultimate, I would say, decision tree, because there is a lot of considerations you may want to think, but maybe this gives you some idea on how what types of decisions we are facing when migrating to the cloud. And one thing to mention is at the end of each iteration, don't forget about the following things. So monitoring and alerting, set it up just to make sure that everything is up and running. You don't need to, log in every day, watch out the system. You will get notified whenever something is wrong. Right sizing and auto scaling. I would also add preemptible instances as a keyword. This is something that will help you get the best out of performance, and also the lowest budget. So you will get the better financial benefits out of that. Also, data retention policies. So cloud storage will allow you to specify what happens to the data after some time, after, like, to specify life cycle for your data. So what you can do, for example, is let's say it's the audit data that needs to be done, needs to be kept for 1, 2, or 3 years. You can specify that after 3 years, this data is deleted. So this is something automated. You don't need to script it out, and so on. And also think about cost monitoring for all those solutions. And this has 2 aspects. You can use tags and have some information on how each specific project is behaving cost-wise on the cloud, and also configure some notifications, budget-related notifications, because cloud is flexible, but it can be something that can blow up to your face if you allow unsupervised use of the cloud, or someone goes wild with the auto-scaling parameters. You may get a really huge surprising bill. This is something definitely to avoid. So those things are to be thought about. Just shortly on transforming the organization, I won't talk too much about this. Just point you out to Google Cloud Adoption Framework. This is a place that this is a framework that tells you it's a Google's vision on how to check and review the transformation of the cloud maturity. So it points out to 4 themes, which is learning, leading, scaling, and security, and tells you, points you out to the behaviors and products and tools you can use to improve this, and also lets you self-evaluate in terms of how mature you are in the way to use the cloud in the optimal way. Okay, to sum things up, migration is a difficult topic because it's very dependent. There is a huge, large amount of variables to consider. Take your time to know the cloud first before making any, decisions that will cost you a lot of budget and so on. This will be the time well spent and worth, some extra budget if you want to take some external trainings and so on, or even work with the partner. It's hard to achieve the optimal solution at the first time. So just, this is a journey. So just try and learn. You can always change or optimize the solution. It's not a win or lose scenario. So you can move, you can get some gains. The more time you will spend on learning the cloud, you will get the better results at the end. And where to go next? If you go for strictly technical guidelines, cloudgoogle.com.solutions. This is their official site. They have some case studies, they have some suggestions, there is detailed descriptions of each service available there. This is a good place when you want the technical knowledge. If you want more concise training, then I can recommend you Coursera courses from the Google category. And if you don't want to go for a cloud journey on your own, then you can find a partner. We are one of the Google partners, for example, in Warsaw, but you can look them all up in the following page. Based on the location, based on the exact thing you want to do, based on the specialization. Okay. Okay, that's it regarding the contents of the presentation. Are there any more questions on your side? So we have a question from Michał. When you mentioned that Dataflow outperforms Dataproc, did you mean only the autoscaling of the cluster, or does Apache Beam perform better than Apache Spark in general? I would say it's hard to tell. Apache Beam is a language which is a bit more will it perform better? We will need a specific use case to measure. Usually, if you consider compare, for example, Dataproc Apache Spark job, then you will get better autoscaling. And if you can imagine that, for example, you can autoscale Beam to run the 1,000 instances or use all the CPU cores available in your quota, I would expect it to get the better results. Okay. Are there any other questions? Okay. We'll have some questions from YouTube as well. The question is, does Dataproc mean lift and shift? Hope new development done as well. So Dataproc allows you to run the same Spark job you will run on your on-premise cluster. The only difference is regarding on where the data comes from. So usually on-premise, you have either some local file system or you store the data on HDFS. For the cloud, it's better to use cloud storage for storing all the data separately to the cluster, and then it's fairly easy to point your Dataproc jobs to this new location. There are connectors for Dataproc for Google Cloud Storage or even for BigQuery to do that. So this is especially this is the one thing that's worth doing, even if you don't want to change anything else in your job, because what this will allow you to do is not to keep the cluster running all the time, but use it in ephemeral way. So for example, schedule it, run the single job and shut it down. it seems like we have no more questions. Thank you very much for attending this session. I'm really glad I was able to share this glimpse of my experience with you. I hope you find it interesting. Yeah. If there are any other questions you would like to take offline, I see we have one more question. So the question is how Redis Enterprise or others can do lift and shift. So what I expect is that you just if you want to migrate your Redis instance, it's up to spinning up the cluster with a similar parameters and then do the data migration. As for the moving data to the cloud, it's a bit broad topic. You might want to look up the transfer appliance if there is huge amount of data, or the cloud interconnect. Or if it's like a reasonable amount of data, you can just upload it to Google Cloud Storage and go from that. Okay. Okay, we have one more follow-up question. Does it mean we replace with Redis DB, but still code is need to be rewritten? I mean, if you mean the application code, then I guess it's pointing it to the new instance. I'm not a Redis specialist, but I think in that case, yeah. So you can easily transfer Redis DB in a lift and shift. There is a question, moving VMs into cloud is meant as migration or move, or what term you define? I would say if you move VM, like spin up another instance, there is a tool for that, by the way, in Google Engine, which is called migrate for Google Compute. I would say it's a classic lift and shift. There is a question regarding migration. My experience with migrating Informix legacy to Bigtable or BigQuery. I do not know a lot about Informix. I would say if you can extract this data to JSON or CSV format, moving it to BigQuery or Bigtable is pretty simple. I would add, take a look at storage transfer for Google BigQuery because they may support that. I didn't have a chance to get some experience with the Informix database. Okay, so once again, thank you everyone for attending. It seems like the webinar time is coming to an end. For any other questions, please use the YouTube link. I will try to answer some of them offline. Thank you.